Determination of enthalpy. Change of neutralization using a coffee cup calorimeter. In this experiment, we measure the heat released during the neutralization of hydrochloric acid with sodium hydroxide using a coffee cup calorimeter. This simple method allows us to study one of the fundamental concepts in thermodynamics, the measurement of heat changes in a chemical reaction. By carefully observing the temperature before and after mixing the two solutions, we can calculate the enthalpy change, delta H, for the reaction. The apparatus required includes a coffee cup calorimeter, two 25 milliliter measuring cylinders, a thermometer, a glass stirrer, beakers of 50 milliliters, hydrochloric acid of 1 molar concentration, sodium hydroxide of 1 molar concentration distilled water, and tissue paper. We begin by washing the measuring funnel to ensure that there are no impurities or residues that could affect the accuracy of our measurements, as clean equipment is essential for reliable results. Next, we measure exactly 25 milliliters of 1 molar hydrochloric acid into a measuring flask, making sure to read the volume at eye level for precision. This is our measured hydrochloric acid, ready for the calorimeter. We now unwrap and prepare the thermometer that will be used to measure the initial and final temperatures during the reaction. The measured hydrochloric acid is poured into the coffee cup calorimeter, and using the thermometer, we record the initial temperature, which in our experiment was 27.5 degrees Celsius. We then measure 25 milliliters of 1 molar sodium hydroxide and pour it into the calorimeter containing hydrochloric acid. The reaction begins immediately, releasing heat. The solutions are mixed gently to ensure complete reaction. The thermometer is inserted, and the final temperature is recorded. In our case, the temperature rose to 31 degrees Celsius. Moving on to the calculations, the temperature change, delta T, is final temperature minus initial temperature, 31.0 minus 27.5, giving 3.5 degrees Celsius. The heat released, Q, is calculated using Q equals m times C times delta T. Assuming the total mass of solution is 50 grams and the specific heat capacity of the solution is 4.18 joules per gram per degree Celsius, Q equals 50 times 4.18 times 3.5, which gives 731.5 joules. The enthalpy change of reaction, delta H, is determined using the formula delta H equals negative Q divided by the moles of the limiting reagent. Since both reactants have 0.025 moles, delta H equals negative 731.5 divided by 0.025, giving negative 29,260 joules per mole, or negative 29.26 kilojoules per mole. The negative sign shows that the reaction is exothermic. It releases heat to the surroundings, which is typical for acid-base neutralization reactions. Throughout the experiment, proper lab safety is essential. Wear safety goggles and gloves, handle acids and bases with care, clean up spills immediately, and dispose of solutions according to lab guidelines. This concludes our experiment on determining the enthalpy change of neutralization using a coffee cup calorimeter.